Determine all critical numbers for the function f of x equals x times 6x plus 20 quantity to the 2/3. Critical numbers are the x values that make the numerator and the denominator of the derivative equal to 0 and are in the domain of the function. The first thing to do is find the domain. F of x equals x, a polynomial, which has a domain of all reals, times 6x plus 20 quantity to the fractional exponent of 2/3. The denominator of the fraction is the root. It's an odd number here, and an odd root has a domain of all reals. Therefore, the domain of the function is all reals, or negative infinity to positive infinity. The next thing to do is to take the derivative, f prime of x, which equals, we have a product in our function. We will make use of the product rule. Derivative first will be a 1 times the second left alone, 6x plus 20 to the 2/3, plus the first left alone, x, times the derivative of the second, which is a power rule. Bring down the power, leave the inside alone, subtract 1 from the power. I will call that 3/3, and then multiply by the derivative of the inside to complete the chain rule. Derivative of the inside will be a 6. The first term is 1 times a quantity to the 2/3, which will just give us that quantity to the 2/3. 1 times anything is itself. Plus, and then the second we have the constants of 2/3 and 6. They can be brought together. 2/3 times 6, 2 times 6 is 12 over 3. 12 over 3 is a 4, so that's a 4 with the x. And then we have a 6x plus 20 to the 2 minus 3, negative 1 third power. Each of the terms has a power of 6x plus 20, so we can factor a 6x plus 20 out to the lower power of the two. We have a positive 2/3 power, and we have a negative 1/3 power. The lower is the negative 1/3 power. So we will now factor out a 6x plus 20 to the negative 1/3 power. Factoring is dividing, and dividing is subtraction of exponents. So by factoring out a negative 1/3 power, we will be subtracting a negative 1/3. Subtracting a negative 1/3 is equivalent to adding a 1/3, so we will be adding a 1/3 to each of the powers. 2/3 plus 1/3 will become 3/3 or 1, so 6x plus 20 to the first power. That'll be the first term. And then the second term, the negative 1/3 plus 1/3 will be to the 0th power. And anything raised to the 0th power is a 1. So we'll be left with a 6x plus 20 to the first power, and then plus a 4x times what will be a 1, because it'll be to the 0th power. So we have a 6x plus 20 to the negative 1/3, and in the square brackets we can add the 6x and the 4x. That'll become a 10x plus 20. Negative powers could be moved to the denominator to become positive powers, so the 10x plus 20 will stay in the numerator, and the denominator will now become a 6x plus 20 to the positive 1/3 power. One more thing we can do, we can factor a 10 out of the numerator. And 1/3 power can be written as cubed root, so we can rewrite that as cubed root of 6x plus 20. And there's the simplified version of the derivative. It's in a single fraction, and it has no negative powers, so we can now set the numerator equal to 0 and the denominator equal to 0 to find critical numbers. Starting with the numerator, which is 10 times x plus 2 equals 0. We'll divide both sides by 10. So x plus 2 equals 0. And subtract 2 from both sides, so x equals a negative 2. And now, the denominator, we have a cubed root of 6x plus 20 equals 0. We will cube both sides because the cube of the cubed root will cancel each other out, leaving a 6x plus 20. 0 cubed is 0. We can subtract 20 from both sides, so 6x equals a negative 20. And we can divide both sides by 6, so we get a negative 20 over 6, which can reduce to be, by a factor of 2, a negative 10 over 3. Now we check to see if these x values are in the domain. The domain here is all reals. The first one we had was x equals negative 2. That is a real number, so we keep that one. And the next one we have is x equals negative 10/3. That's also a real number. And therefore we keep that one. And there are the two critical numbers for the function, x equals negative 2 and x equals negative 10/3.